case you want to come back and watch the video again. Alright, so 10.1, here's how you graph the parent cubic function y equals x cubed. I'm going to start by plugging in -2 for x. So -2 raised to the third power is going to be -8, because -2 times -2 times -2 is -8. Okay, let's keep going. Let's plug in x equals -1 for x. So -1 raised to the third power is still going to be -1. If I plug in 0 for x, it's going to be 0. If I plug in 1 for x, then that's going to be +1. And finally, if I plug in 2 for x, 2 to the third power will be +8, because 2 times 2 times 2 is 8. So that's how you would start graphing a cubic function. Now just take these points and graph them on the grid. I like to start like at 0, 0, which is the origin here. And then I like to graph 1, 1 and 2, 8. 2, 3, 4, 5, 6, 7, 8. And then I like to connect those dots like this. Your graph is going to be concave up right here. For the negative side, it's sort of symmetrical, just like kind of backwards. I'm going to do -1, -1, and then -2, -8. Oh, and remember, for those of you guys that are online, you have to have some graph paper. Either purchase some graph paper or print out the graphs that I'll provide for you guys on the quiz and test. If you're in the room, I can give you graph paper. But that's what the parent cubic graph looks like. You need to know the name of this origin point here. So this 0, 0 point has a name. It's not called the vertex anymore. It's called the point of inflection. So let me write that down, because you do need to know that's what it's called. Point of inflection. So I will ask you, like on the quiz and test, what is the point of inflection for this function? And you need to know that that's this middle point here. The reason why it's called the point of inflection, you don't need to know that, but just in case you care, is because from this point, like to the right, your graph is concave up, but to the left of that point, the graph is concave down, like the shape. You don't need to know that. All you need to know is that's called the point of inflection. And it has another name, just because math is complicated. It is also called the point of rotational symmetry. Let me write it down. Point of rotational symmetry. I never call it that, but for the district assessment and the district quizzes and stuff, they call it point of rotational symmetry. So I guess just be familiar with the names. So one more time. 0, 0. That's called point of inflection / point of rotational symmetry. And then I think the rotational symmetry is because, I don't know, if you try to rotate the graph along this point, like I don't know, turn it around, it would be symmetrical. But again, you just need to know what they're called. So now let's go ahead and fill in this information. Here's why cubic functions are easier than last semester. That's because the domain and the range are always all real numbers. So we're not going to have to worry about domain restrictions or anything like that when we do inverses or graphs or anything like that. So the good news is cubic functions always have a domain and a range of all real numbers, always. So that's going to make them easier. X and Y intercept for the parent is just 0, 0. And that's all you need to know for the for the parent function. Now you need to know how to graph transformations. So first, let's pause for questions. Okay, so you need to know how to graph transformations of the parent function. So here are some transformations. The values of A and D, those are called vertical transformations. Vertical transformations. They're going to affect your Y values. Affect Y values. So if there is an A or a D, those are gonna change your Y values. Next we have the B and the C. These are called horizontal transformations because the B and the C are inside of the cubic function. Like B is being cubed and the C is also being cubed. So they're called horizontal. And those are affect the X values. Affect X values. So that's all you've got to know. And now we can actually try some examples and graph these together. So let's graph numbers 1, 2, and 3. We're just going to practice graphing these transformations. On the quiz, these are like multiple choice, so you would just have to like look at the graph and see which one matches your graph. So let's start with the first one. This very first graph, there's different ways to graph this. I'm going to show you the way I do it, and then I'll show you like a backup if you don't like my method. But here's the Mrs. Garcia way. What we do to graph this function, we first graph the inflection point. So your inflection point is always going to be at the origin if there's no shifts. So if there's no C or D, like on number 1 here, there's no shifts, then my inflection point is going to still be at 0, 0. So that's what I do to graph. I'm just going to graph 0, 0. And then I'll do my stretches. However, when there is a shift, like if you take a look at number 2. Number 2, notice how it says x plus 6 cubed plus 6. That inflection point has been shifted. It's been shifted. It's no longer at 0, 0. So this inflection point has actually been shifted to negative 6, 6, because although it says the x plus 6, just like last semester, that means you have to shift to the left 6. So let me do that. 1, 2, 3, 4, 5, 6. And then you have to do the plus 6 on the outside. That does mean up 6. So 1, 2, 3, 4, 5, 6. So there's my inflection point. And then I'll show you how I do the stretches. Let's practice one more inflection point, which is going to be number 3. Let me put a little star by that to warn you. That's kind of like maybe not a trick question, but that's the hardest question kind of that you'll see. See if you can figure out the inflection point for that. I'll give you a minute. See if you can figure out the inflection point for that one. And your hint is that it's not going to be 8, negative 5. That would be wrong. So think about it. It's not going to be 8, negative 5. Think about what it will be while I finish the attendance. Okay. Hopefully you figured it out, the inflection point. Where did I leave my answer key? I mean, I guess I can just wing it, but I had an answer key for this. Oh, I think I know where it is. But anyway, so the inflection point for that should have been 4, negative 5. And the reason why it's 4, negative 5 is because on your function here, you need to factor the 2 correctly. So I'm going to put y equals 2 parentheses x minus 4 cubed minus 5. Okay. So that's what you need to do to your function before you can tell the right shift or the right inflection point. So example number 3 should be written as y equals 2 parentheses x minus 4 cubed minus 5. And therefore the inflection point is 4, negative 5. So let's graph it. 4, 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. Okay. So recap. So far I'm just showing you how I graph these functions by first graphing the inflection point. So first graph the inflection point. Okay, next here's what I do to graph them. I guess let's go back to number 1. So once you have graphed your inflection point, now you're going to use the parent points, like I guess kind of like a pattern. So from the inflection point, you're supposed to always go 1, 1, so to the right one, up 1. And then from the inflection point, you're supposed to go 2, 8, like to the right 2 and up 8. So that's what I'm going to do here on number 1. So from the inflection point, I'm going to go 1, but instead of doing 1, 1, here's what I'm going to do. I'm going to go 1 to the right, down a half. So the reason why I went down a half was because there is a negative 1/2 here that's going to be affecting your y values. Negative 1/2 is called vertical transformation, and is going to take your y values and multiply them by negative 1/2. So again, the point that was 1, 1 now became 1 negative 1/2. So let's do the other point. Remember, the other point should have been 2, 8. So I'm going to do from the inflection point, I'm going to go to the right 2. But then instead of going up 8, I'm going to go down 4. 1, 2, 3, 4. Because again, I took the y value, which was 8, and I multiplied it by negative 1/2. So it became negative 4. Okay, now do the graph, or concave the graph. The other side should be sort of symmetrical. So on the other side, I'm going to do to the left 1, up 1/2. Then I'm going to do to the left 2, and up 4. 1, 2, 3, 4. So, okay. First of all, that's how I graph these. If you like that method, do it. If that didn't work at all, you're like, what's she talking about? Then these are multiple choice. You're just going to have to select it. You could always just make your own table of values here. Like, make your own, pick your own x values and plug them in here and find the y values. So sort of what we did with the parent, you could always just do that if you want to make the graph. Either one's okay. So let's try it again. Kaden, do you have a question again, or did I just forget to lower your hand?
Yeah, I have a question.
What is it?
Down or up 4, do you go like down 4 from the previous point, or from like...
No, you go down 4 from the inflection point.
Oh, okay.
Yeah. So let's do it again, and I guess, Kaden, hopefully this will help. So let's try number 2 with that. So remember, first we graph the inflection point, so that's already done. Negative 6, 6. Okay, remember, so I guess just kind of pretend that this negative 6, 6 is the origin. Like that's still your 0, 0, your origin. So from here, if there was no stretches or shrinks, then I would just do to the right 1, up 1. Or I would do to the right 2, up 8 from the inflection point, if there were no stretches or shrinks. However, there is a negative 2, which again is another a value, so that will affect your y values again. So that means from the inflection point, instead of me going to the right 1, up 1, I'm going to go to the right 1, down 2, because I did 1 times negative 2 is negative 2. Okay, let me try it again if that didn't help. So again, from the inflection point, according to the parent, I should do 2, 8, because 2 cubed is 8. So I should do 2, 8. So from here, I should be doing 2, 8. However, because there's a negative 2 there, I'm going to do to the right 2, and then 8 times negative 2 is negative 16, so down 16. 1, 2, 3, 4, 5, 6, and then I guess this is 10. So it's going to be way over here. So from the inflection point, I went to the right 2, and then I went down 16. And then it kind of goes like that. Remember that the other side is, I guess, like symmetrical. So I'm going to go to the left 1, up 2. And then I'm supposed to go to the left 2 and up 16, but that ain't going to fit. So I guess, like that. And if all else fails, then just make your table of values here and start plugging in some numbers. When you do make your table, like if you want to make a table of values because you didn't like the Mrs. Garcia method, always start with like the inflection point, so like negative 6, 6, and then from there pick like a few points after the inflection point and before, so like you can do like negative 7 and like negative 5. Plug in some points. Same thing like on this one, start with the inflection point and then you can do like negative 1 and 1. So if you just want to start plugging in points, that's okay too. Plus the thing is multiple choice, so select the one that looks right. pausing for questions. Alright, to finish off graphing, let me show you number 3. Number 3, remember you always just, to graph, I always graph the inflection point, which we already did, for -5. -5, got it. Okay, now we need to do the stretches or shrinks. And this 2, since it is being cubed, like it's inside of the parentheses, that's called a B value. And with B values, you have to remember that those are going to be like the reciprocal of what you see. So even though you see a 2 there, that's actually a horizontal compression by half. So here's what that looks. From the inflection point. Again, one more time. If there was no stretches, I would just do from the inflection point, I would do to the right 1, up 1. And I would do to the right 2, up 8. If there was no stretches. However, there are stretches or shrinks, so here's what I'll do. Instead of doing to the right 1, up 1, I'm going to do to the right half, up 1. And the reason why I only went to the right half was because this 2 is a horizontal compression by half. So that means you're going to change your x values by half. So I did half to the right and up 1. So let's do it again. The other point should have been from the inflection point, you should go to the right 2, up 8, like that's the parent, 2, 8. However, here we're going to do, instead of doing 2, 8, I'm going to do 1, 8. So to the right 1, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So right here, and that's concave up. Then you can try the other half of the thing. It should be sort of symmetrical. And still can't find my answer key, so I guess. Alright. The other half would be to the left half, down 1, or to the left 1, down 8. That's not gonna fit. Okay. So it would look like that. And finally, one last time, if all else fails, just start making some tables here. Always choose the inflection point, so for -5, and then choose a point after and before the inflection point. And now what you would do, just take your x value, plug it in here, like 2 times 5 minus 8 cubed minus 3, or do the same thing with x equals 3, 2 times 3 minus 8 cubed minus 5, so that you can make a table of values if you want it that way. So that's how I graph. You just need to know how to graph. These are just multiple choice, so test and quiz, multiple choice. Now I need you to try this part here, the domain, range, x, y intercept, and see if you remember how to do the minimum / maximum on an interval. So try that. Let me pause while I finish the attendance finally. Here are the answers. I just said domain and range is always all real numbers. We already did the point of inflection. X and y intercepts for number 1 is 0, 0. Let me remind you how to do the x and y intercepts for numbers 2 and 3. So the way you'll do any x-intercept is I need you to plug in 0 for y and solve for x. And then for the y-intercept, I need you to plug 0 for x and solve for y. So here's what I mean. I guess let's do number 2. Let's do the x-intercept. Let's plug in 0 for this y equals. So let's put 0 equals. Let's put it right here. -2 parentheses x plus 6 cubed plus 6. Okay, I need you to solve for x now. And we did these last semester with square root and quadratic, so it's very similar. To solve for x, let's isolate the x quantity. So I'm going to do a -6 equals -2 x plus 6 cubed. I'm going to get rid of the -2 by dividing both sides by -2. So -6 divided by -2 is 3 equals x plus 6 cubed. And then just like last semester, when we had squares, we did square roots. Okay, this is a cubic, so you're going to do what's called the cubic root. And the cubic root is the radical symbol, like the same symbol, except for you put like a little baby tiny 3 there. It's called the index root. and that's how you write a cube root. And now we evaluated the cube root of 3. There isn't one, so we're just going to leave it as the cube root of 3 equals, the cube root should cancel the cubic, and you're just left with x plus 6. Another reason why these cubics are easier than last semester is that we don't need the even, odd rule anymore, because you're taking like an odd root, so it doesn't apply for the even, odd rule. So that's why the whole cubit section is just easier. So finally, for my x-intercept, subtract the 6. So my answer will be cube root of 3 minus 6. And that would probably be multiple choice on your test and quiz, because it's very hard to type that, but cube root of 3 minus 6. So that's how you find x-intercepts. So now let's do a y-intercept. To find your y-intercept, plug in 0 for x. That one's going to go a little easier, I think. So I'm going to do y equals negative 2 times 0 plus 6 cubed plus 6. And then you just do some math here. Negative 2 times 216. Yeah, 6 cubed is 216. And then you multiply that out. Negative 2 times 216. 12. 2. 12. Oh, that should be a 3. And a 4. Negative 432. Did y'all get negative 432? Plus a 6. Because I don't have my answer key. And then y equals negative 4. Whoops. Negative 426. No. Olivia? Yeah. Okay. So negative 426. And then I'm pretty sure on the test and quizzes I try to choose like smaller numbers, because we don't have calculators, so just smaller numbers. That one wasn't too bad. Negative 426. Okay. That's how you find x and y intercepts. So why don't you try, well, like, I'm going to find this answer here. I guess I'll just look online. Try to do the same thing for example 3. When I click on the key here, find the x-intercept, find the y-intercept, and then we can finish the front of this. Let's see. Okay, let me pause for you to... Alright, so now I need you to remember how to do max and min values on an interval. Here's how you do those in case you forgot. You're looking for the maximum or the minimum y value. You're always looking for y values based on some x interval. So this is like x is in between negative 1 and 3. So let's try number 1. I need you to look at the graph from only x equaling negative 1, so right here, up to x equals 3. 1, 2, 3. Okay, yeah, these are definitely on your quiz. Either multiple, I think they're fill in the blank or multiple choice. So now you need to tell me where's the minimum value. So looking at the graph, the minimum value is going to be where the x is equal to 3, because that's the minimum. That's the minimum. At x equals negative 1, that would have been the maximum. So my minimum value will be somewhere where x equals 3. So now let's find it. The way you would find it is you just take x equals 3 and plug it into your function so that you can find the y value. So I guess I'll do it right here. Negative 1/2 times 3 cubed. That's going to be a negative 27 halves. Yeah, negative 27 halves. So that's how you would find a min. I'm going to skip number 2 because it's a very big number, so you can skip it. Try number 3. I don't like this one. I need to fix it. Try number 3. Find the maximum from negative 3 to 5. So again, only look at the graph from negative 3, which is way over here, up to 5. 1, 2, 3, 4, 5, Oh yeah, looks like this. Okay, so if you notice on number 3, the maximum would happen at the x equals 5, and it looks like it's just, you can see it from the graph. When x equals 5, the y value is 3. So that's how you will need to know how to find max and mins. And then the last thing you need from the front here is the transformations, and those will be multiple choice. Like on your quiz and test, you just have to select the correct transformations. So look at number 1. You do have an a value of -½, so when you write the transformation, you would say vertical, since that's an a value, it's called a vertical compression by half. And like I said, these are multiple choice, so it doesn't matter how you write it. And then one more transformation on number 1 is that negative. If it's an a value that's negative, that's a reflection over x-axis. Don't get confused with those. If the a value is negative, it does need to be x-axis. If the b value is negative, you would have to put the y-axis. So that's number 1. There's 2 transformations. Okay, number 2, I don't have room to write it, but if you do write it, it should just be reflection over the x-axis again. This time vertical stretch by 2. There's also a horizontal shift to the left 6, so -6, and a shift up 6 because of this one, +6. So again, multiple choice, you would have to do it. Let me do number 3 because that one is the horizontal one, so let me write it. Number 3. So because there's a b value that's equal to 2, you would say horizontal compression by half. And then you would say, because it's x minus 4, you would say horizontal shift. I'm just going to say right 4. And the last one, which is the -5, it's vertical. Down 5. So now I'm going to pause for questions to see if you have any. If you don't have any, try the next example on the second page. Pause for questions. Examples on the back. Here's how you do those. Alright, so you need to be able to give me the equation based on the graph. So let me tell you what the general equation is. It's always y equals a parentheses b parentheses x minus c parentheses cubed, don't forget the cubed, plus d. So here the c and the d are the inflection point. So let me write it out. C comma D is your inflection point. So that's going to be very important. And then the last thing that's going to be very important, and why the cubics are always easier, we don't need both A and B. We just don't need them. We only need one of them. So you just pick your favorite, and your favorite should be A because that's easiest. So what we're going to do, we're always going to let B equal 1. So I'm going to put it here. Always let B equal to 1. And that's going to work always, 100% of the time, with the cubics. It didn't work with the square roots and the parabolas because that was something else. They're harder. So anyway, so we're going to do, let's pick number 5 here. You can do 4 or 5. So for number 4, let me just use what I just said. So I'm going to write y equals A parentheses. I'm going to ignore B because we're always going to let it be 1. So just gone. X minus, let me find the inflection point. Sometimes students have issues finding the inflection point, but it should just be the point where the graph changes, what's that called, like concavity, like it goes concave up, concave down. So this is my inflection point, 4 comma 1. So I'm going to put 4 here. Don't forget the cubic, plus 1. So my inflection point is 4 comma 1. My A value is unknown, so put A. And just like you did last semester, to solve for the A value, the best way to do it is just to plug in the other point that's given. So plug in 2 for X, plug in 4 for Y, and that should be able to give you the A value. So, let me just do it. 4 equals A, 2 minus 4 cubed plus 1. Solve for A, so I'm going to subtract 1. 3 equals A. 2 minus 4 is negative 2 cubed. So it looks like A would be 3 divided by negative 8. That looks right. So for my final answer on number 5, I would put f of x equals negative 3/8 x minus 4 cubed plus 1. I want to remind you how to type these into your test and quiz. Most of y'all obviously were here last semester, so you know how to type these. But for those of you that are new, maybe I can help you and give you some practice. But these are fill in the blank. Like, it's going to ask you, like, what is the A value? I'm not even going to ask for the B value because it's always 1. What is the C value and what is the D value? So remember that you need to, like, type it in correctly. So for number 5, our A value was negative 3/8. So type in negative 3 divided by 8, no spaces. The C value was 4. So type in 4. The D value was 1. So type in 1. These are like fill in the blank for your test and quiz. So type them in right. You definitely need to know how to do that one. And last but not least is number 6 and 7. They're both the same, similar. We're just going to do number 6. And then you try number 7 by yourself. We did these last semester. Here they go again. Last semester we did them with absolute values. We did them with parabolas and square roots. So here they go again. Number 6 and 7. Given some f of x function that has already been shifted, write a new function g of x so that g of x has these following transformations. So for that, here's what we do. Here's what I do. I go in and look at g of x. It equals 1/3 f of 2x minus 4 minus a 5. So first of all, I need to figure out what is f of 2x minus 4. So I'm going to go over here to the f function, and I'm going to find what is f of 2x minus 4. The way you find f of 2x minus 4 is you plug in 2x minus 4 for the x in the f function. So in other words, f of 2x minus 4 equals 2 times x cubed plus 3, and I just said it, you replace the x with the stuff in parentheses, 2x minus 4. So there we go. That's the answer for the f of 2x minus 4. However, for your final answer, remember your final answer is g of x. For your final answer, we need to take what we just got, multiply it by 1/3 and subtract 5. Because that's what g of x equals. It equals 1/3 times f of 2x minus 4. But instead of writing f of 2x minus 4, let's go ahead and write what I just got. I got 2 parentheses 2x minus 4 cubed plus a little 3. And then don't forget there was still a minus 5 at the very, very end. So that's going to give you your final answer. Try simplifying that, and that will give you your final answer. So g of x is going to be 1/3 times what we just got minus 5. So in other words, g of x equals 1/3. 1/3 times 2 is 2/3. Parentheses 2x minus 4 cubed. And then you're supposed to do 1/3 times 3. So 1, that's 1. And then at the very end, there's a minus 5. So final answer, and 2/3 parentheses 2x minus 4 cubed minus 4. Just double check the answer key. That looks right. You could leave the answer like that, but I definitely did put this on the test as well, or the quiz /test. Instead of leaving the answer like that, on the test and quiz, again, it's going to tell you like, what is the value of A? This one will have what is the value of B, what is the value of C, and what is the value of D. These are fill in the blank kind of thing. So see if you can figure that out. Like, what would be the A value? And I will give you like the generic function. Remember, it's A, B, X minus C. So try practicing right now, just like filling in the blank. According to this, the A value would be the 2/3. The B value should be the 2, like it's just a 2. It's called a horizontal compression by half, but the B value is a 2 itself. Okay, you have to be very careful with the C value. That's where some kids mess up. The C value, it's going to be a 2 because you have to factor that out. We're going to have to write this as 2 parentheses, kind of like that. Minus 4. And finally, D is minus 4. That's that one. And then you should probably finish this last one. Number 7 is the same thing as number 6, except for you're going to have to take like all of these words and write them in a function. I'll write it for you if you want to copy it, but let me write down real quick before you leave. X minus 4? Okay. So all I did on number 7 was I made it look like number 6 by taking all of these transformations and writing them as like g of x equals -½ because of the x-axis reflection, vertical compression by half. And then I did f of x minus 4 because that's a shift to the right 4. And then minus 5 because it was shifted down 5. So that's a lot of me talking. But for the rest of the weekend, please do the online textbook homework because it is part of a grade. Download the Lockdown browser so we can be ready for our first quiz next Tuesday. And that was it. It was nice to see y'all. Here's your friends again. It was nice to see all of you. I wish you a good second semester. Adam just got to class right on time. Let's let him in. David, question? Bye guys, I'll see y'all next Tuesday. David, do you have a question or are you just saying hi? What's the question?
Skyward, like when I looked at the curriculum part, it said that my algebra 2 was like dropped.
Yeah, I don't know. There's like 5th period got totally messed up in Skyward and Teams. I have so many multiple 5th periods. So I have your grade, David, somewhere. I need to transfer it to the new 5th period class. So they're there. Like I haven't lost any grades, David. Like it's there somewhere. I'm just gonna have to go and find your grades and transfer them so I can add you back to this class. No, I think you're in this class, aren't you? I don't know. Hold on. Let me go find you, David. No, yeah, you're in this 5th period class. But what's the question? Yeah, David, I think you're in this class. Just I'm gonna transfer your grades. I'm gonna transfer your grades later. Let me just confirm. David. Oh, that's wrong. Where's David? Yeah. Okay, David, you're okay. Don't worry about it. I'm gonna fix your grades and I'm gonna transfer all our stuff into the right section.
Okay, thank you.
Alrighty. Camila, do you have a question? You're a new kid.
Yeah, I was wondering if the homework is already posted in the textbook.
Yes, but
back here and I didn't see it.
yeah, but you know what, Camila? Because you're from like Elkins High School, and I don't know if you're in. The answer is yes. It should already be posted. You can't see it in the online textbook.
No.
Okay, I think you might be one of my kids that wasn't added to my class for the book. So I'm gonna have to fix it for you. I think for now, just just do the little do now in today's folder so that I know you did something today. Where is it? In our folder for today, there's a little do now here. Go ahead and do that, like for your homework grade today, like completion grade today. And then I'll let you know what I find out about adding you to my right class, okay?
Okay, thank you.
Thank you. I'll see you later. Kaden, you don't have any questions? You left. Okay. What else? Who just got here? Okay, Adam and Hannah, welcome to our class. Hello. Let's see. Adam, welcome. Hannah, welcome. I'm Mrs. Garcia. I wanted to tell you that because of my schedule, I have class. Oh, wait. Did I pause this? Gosh darn it. I forgot to